This is part 4 in the video series demonstrating how to deal with reference propagation between models. And we want to take a closer look this time at patterns and how the choices for reference propagation impact the ability to pattern. Again, we're using kind of a simplified example of a side motion assembly. And let's start by going ahead and taking a look at the skeleton part and some of the changes that I've made to it. So let's zip this up. And let's open up just the skeleton part. One of the things you'll notice right away is we still have our same 3 surfaces we had before, our same 3 quilts. But I've also created 3 additional datum planes. And these are going to be used, or are being used now, for the placement of the punch that this is going to be cutting in our assembly. To make this a little easier, one of the things I did is I created a datum axis inside the first extrude, inside our first triangular quilt. This is created automatically by simply putting a geometry point in the sketch. Let me just show you what that looks like. So if we go into the sketch itself, in the center of my sketch, I added one additional point here, and it's a geometry point, meaning it's this one here. Anytime you put a point in a sketch, and then the sketch is extruded either as a surface or as a solid, that point becomes a datum axis. So it gives us our axis right through the center of this shape, and then that axis was used to place or create additional 3 datum planes. So I've got my plane that's been renamed punch top, one that's been renamed punch side, and then an additional plane that was created as an offset. I can show you that. It's just created as an offset from the front plane of the model back a certain distance, and that's going to be where the end of our punch stops as it enters into the post. Okay, so those 3 planes are going to be pretty important later, especially if we look at potentially patterning the punches. Say that 10 times fast. All right, let's hide this. We have our triangular shape here. I'm just going to show the inner shape for now. And let's go ahead and turn off axis display and plane display. So if we go back out to the shell in the assembly and we turn on display of our quilt that we're going to use to cut, one of the ways we had discussed cutting the surfaces was just to select the quilt and then directly copy it. So if we activate our shell part, we select the quilt itself, we choose solidify, and then remove material. All right, we get our triangle cut in the model. Okay, but now what if there are 7 of these around the circumference of this shell? We could go into the shell model here. We could pick on this one solidify. We could say, hey, we need to pattern it. Let's do it around the axis of the shell itself. We'll pick the center, and maybe we want, I don't know, 5 of them equally spaced, and there's our 5 cuts, right? The disadvantage of this approach, though, is we've just independently defined the quantity of cuts and really their positions inside this shell model all by itself. There is no relationship between what we just did and the stripper or the punch locations or the skeleton. So it really would be better to let these positions be driven by the skeleton model instead of this individual model. So let's delete this. Let's delete this feature here, and let's go create a pattern in our skeleton model. So if we expand our skeleton model, activate that, and we pick our extrude, and we do a pattern. We'll do a similar pattern. We'll use an axis pattern. In this case, I'll pick my center, and maybe I want 7 of them equally spaced. And now we have 7 extrudes that represent how many holes I'm going to need in this model. Okay, so now if we go back to the shell, the first thought is, well, we already have a solidify. It's already removing material. Since this extrude is patterned in the skeleton, I should be able to select this feature and automatically pattern it, get a reference pattern, but I can't. And there's a reason for that. The solidify itself is referring to a quilt, not a feature, and the feature was the thing that was patterned. If, on the other hand, instead of doing a direct solidify, we remove this solidify and copy the quilt into this model first, that we can pattern. So we'll switch our selection filter to quilt. We'll pick the quilt from our skeleton model, and instead of doing solidify, I'm just going to do copy and paste. We could have also done a copy geom feature or publish geom feature, but we have this surface that's been copied into this model. Now if I open up the shell by itself, just to make it easier to see, the shell will allow me, to take and select this copied feature and do a reference pattern based off of the skeleton. Then I can take and pick the first quilt that was copied, which is this one here, the first pattern member, pick that one, do our solidify, remove material, hit OK, and since this solidify feature was created from a member of a pattern, I can also do a reference pattern on the solidify. And all the holes are cut. Okay? And the beauty of this is now these are all being driven by the skeleton. If the skeleton changes the quantity of these or the spacing of these, the shell is automatically going to update. All right, so let's go back out to let's go ahead and hide. Okay, so that's great. We created a pattern, right, of just this one quilt. But the problem is now when we go to cut the stripper, we're going to have this quilt. And instead of making a pattern of this quilt separately and this quilt separately and the plane separately, it probably would make a lot more sense to pattern all of these together. So let's open up the skeleton model and let's delete this pattern here. Okay, I'm going to unhide these just so we can see them. All right, so there's my planes, there's my axis, there's everything I need. It's going to get a little bit messy here a second, but if I take all of these items here and I put them in a group, I can then group the entire pattern. Again, we'll do an axis pattern. Pick our center. Let's do a different number this time just for fun. Let's do 9 of them, equally spaced. Hit OK. All right, so it's a little busy because every one of these has its own set of planes unique to that location. We really don't need to see them. And in fact, if you do a hide here on some of the items, it really just hides them for the first set. Let's just hide, you know what? Let's just hide them all. And then if you do edit definition on the pattern, it will re-hide all the rest of them. Actually, I can just edit definition on the group. Let's do that. Edit definition. Just hit OK. And everything else should be hidden. Okay, and to make it even less confusing, we could even just hide the rest of these groups, right? We really don't need to see them. What's really important is that the pattern is created here, and then the features that we're going to reference are part of that pattern. In order to get the reference pattern functionality to work, these features that we want to pattern in the subsequent models need to be part of a pattern in this skeleton model. So let's save this. Let's go ahead and get out of here. Actually, we're going to need to see the extra quilts. So let's unhide those two. Let's go back to master rep. Yeah, master. Oh, they're not on master rep. They're hidden. Let's resume the other models so we can see them. Okay, and let's take and activate the blue model. Our stripper. Let's grab our quilt again for the stripper, which is going to be this one here. Let's do a Control-C, Control-V, paste. We'll come back to that model in a second. Let's pick the blue one. Actually, you know what? Yeah, we better deal with that now because we don't want to accidentally select the blue quilt. So let's open up this model. Same process. We're going to pattern the copied feature first. All right. And then we're going to use the first quilt in that feature, which is this one here. So let's switch to quilts. Pick our quilt, hit our solidify, remove material, flip it the other way, hit OK. And then pick our solidify and do the reference pattern on that one. And we end up with all of those cut. Okay, let's get out of there. Let's go to the punch, or the post. Let's activate that. Same process. Let's go to quilts. Select the quilt that's going to be used for the post, which is this one here. Copy, paste, hit OK. We don't even have to go open it up separately. We can just deal with it right here. So if we just pick on this, hit pattern, get our pattern there, and then pick on our first quilt again. Make sure we get the right one. We want the one that's in post 1, which is the one we're doing. Pick that, hit solidify, cut, keep the bulk of the material, pick our solidify, and then, oops, let's pick solidify. Lost my pattern. I must have solidified the wrong one. Nope, that's the one. Let's open this up and take a look at it and see what I made a mistake on. That should be the one. Ah, there it is. All right. And then the last thing we need to do is the punch. I had mentioned the planes that we created. Those are currently being used to place this punch. If I do an edit definition on the punch, you'll be able to see that the punch side plane in the punch model is now attached to the little skeleton plane that was created specifically for the punch. The punch side in the skeleton, same with the top, same with the front. So this punch is entirely placed off of those extra skeleton planes we created. So let's go ahead and activate our punch model. We will go to quilts again. We'll select the quilt that needs to be used for the punch, which is the smaller one. Control C, Control V. Again, we could be using a copy gem feature. I'm just not in this case. We're going to take, and this one's not going to be patterned because we only have one punch here. So in that case, we're just going to take the quilt we copied in. Make sure I get the right one, that one there. Solidify, remove material, and we want to keep the center. Hit OK. And now what I'm going to do is go back and just hide my skeleton for now. I just don't need to see it at all. All right, so there we have the punches. We have all the holes cut all the way through. The shell does not look correct. Let's figure out what's up with our shell. Aha. We just hadn't regenerated the shell since we changed the pattern quantity from 7 to 9. So if I would have just done an assembly regen, it would have done okay as well. But there we go. We can see the stripper, the shell, and the post on the inside, all having the right stack up. Matter of fact, let's put it in a cross section here, and we can see the clearances now that everybody has all the way inside. All right. And what's nice about this is we can actually use the skeleton's pattern. Because the skeleton's pattern includes the placement references for our punch, we can use those that pattern and those references to actually pattern the punch itself. Now, you wouldn't want to do this if this was mechanized, because mechanized components don't move correctly or won't automatically move if they're part of a pattern, right? So if this punch was configured to be able to slide in and out to simulate the actual motions inside the working tool, when you pattern it, the rest of them aren't going to automatically move in and out. So really what you'd want to do is just assemble this same punch multiple times if you wanted to mechanize all of them together. But for the purposes of what we're doing right now, we're just going to pick this punch and we're going to say pattern. You notice it's allowing us to do a reference pattern because it was placed off of those same references. And immediately I have the number of punches I need. They all intersect the part at the right place. They all enter to the same consistent depth, again, because of those skeleton references. And The beauty of this approach is if I go into this skeleton model and we decide we want to change the quantity, let's say instead of 9, we only want 5. Now I have 5 punches. All the locations are up to date. Every single model has the right number of holes in it all the way through. I can turn it into wireframe. Let's just see that. Okay, 5 of everything. Same goes for the shape, right? So if we went to our master shape right here, do edit definition on this. Let's throw it into a sketch orientation. Let's say we don't want to delete that axis we've got in the middle. That's important. That datum point is important because it's driving lots of other things. So we don't want to accidentally delete that. But we could certainly delete the triangles and the related circle. We could throw something completely different in here. Let's grab something from the palette. Let's go with, let's do another star. Let's do a 9-tip star. Why not? Pull this guy down right on our point so everything stays centered up correctly. Let's make them a little bit bigger. Now this is probably bigger than the yellow punch is when we start, so we may need to increase the size of our material that the punch is being created from. But it'll still be a good demonstration. So hit OK here. And again, we just do a regen on everything. And immediately, all the punches are up to date. The clearance holes are up to date. Let's put in a cross section. All the way through all the models. No failures. No missing references. Everybody's happy. So this is an approach that I would encourage you to consider when you're building complex assemblies where you need consistent clearances between components, and then you want those clearances to propagate through all the pattern members.